Okay. Yeah, so I have office hours every Monday. You can get to those office hours really easily. Just go to this URL. So calendly.com/coder NHFPL, and you can go and you can attend like these office hours just by signing up. If one of these times doesn't work for you, that's not a problem at all. Like just send me an email, and my email is at coder@nhfpl.com. So or .org. Maybe I should put that in the. Actually, Celeste, could you put the email in the chat? Like, oh, okay, great, perfect. Yeah, so Celeste is going to post the email in the chat. So if you ever have any questions outside of these office hours signups, or if you want a different time, like maybe something that works better for you, please don't hesitate to email there. But yeah, otherwise, definitely take advantage of these. You can ask like any questions you want. I don't really have a limit on what I'm interested in talking about. I mean, if it's related to programming, I can try to help you out. Okay, so yeah, great, perfect. Yeah, so that's the email. All right, so I think we've waited long enough. Yeah, should we go ahead and get started? Okay, great. Okay. Okay, so we're gonna do two of these sessions. This is the first one, so if it's a bit bumpy or like it's a bit rough around the edges, that's why. It's like we've never done this before, so it's, hopefully be pretty interesting. But I want to try to make this a little bit more freeform. And the goal of today's session is basically walk through how you approach solving problems or working through an algorithm using code. So using programming to solve what seems like a difficult task, or a task that would be very, very difficult to do without a computer. And I like this problem a lot, though if you go back, you can see there's all kinds of problems. There's all kinds of problems on this Project Euler website, a lot of them related to mathematics. But I like this problem a lot because it's something that you can really easily think about in your mind, just knowing very little about mathematics or programming. Like it doesn't require any of that. So I think we can all kind of relate to this problem. So yeah, I mean, basically, let's just like jump into it and we'll kind of see kind of what's needed, what comes up as we go along. So yeah, so first of all, you're given the following information, and you might want to do some research. Like given some of the information here, maybe you want to look into like some of the other particulars about dates and times and things like this. But basically, the 1st of January 1900 was a Monday. And then we're kind of given this classic like mnemonic, which some of you probably have heard before, or when you were a child, you probably encountered it before. But it basically is giving us how many days are in a month, given the month. And then it gives us some information, a little bit about leap years. And then this last statement here goes into more detail about leap years. So basically, a leap year occurs on any year that's evenly divisible by 4. That means that there's no remainder in the division. And a leap year doesn't occur on a century, so meaning like the year 1900, the year 2000, the year 3000. It doesn't occur on a century unless that century is divisible by 400. Okay, so given all of that information, it's asking a pretty simple question here at the end. So the question is, how many Sundays fell on the 1st of the month during the complete 20th century? So it's giving us exactly what this 20th century entails here. So it's saying from January 1st, 1901 to the 31st of December in 2000. Okay, so maybe we can kind of break this down into like the most relevant pieces of information, which is what I typically like to do if I'm solving a problem like this. So what I'm going to do is I'm going to go over here, and we can see already that this is like, there's some things that look like just English, and there's some things that look like code. This section looks like code to me, and this section looks like English. So hopefully you can kind of understand at least that distinction there. And what we'll do is basically get rid of a lot of this English because they're just explaining what the playground is for. And we'll put in our own kind of thoughts as we work through this problem. And that's kind of, I guess, like a first tip or a preliminary tip when doing something like this is to work out exactly what you're thinking about in a concise way so that you can program it. Because the idea behind a program is to basically, approach the problem in a programmatic way. So we're going to handle the problem bit by bit. And so it's important to clarify what those pieces that we want to like approach are going to be. Okay, so I guess I should also explain what this playground is just briefly. This playground is basically going to let us run TypeScript code using the web browser. So you don't need to install any software to run the TypeScript code. You can just use the web browser to do this, and that's what this playground is. So these are comments, the English text here. These are comments. It means that this code that isn't going to get executed, like it doesn't affect any of the code that we write. We could spell things wrong. We could delete this. It doesn't change any of the code here. This is code, like actual TypeScript code. If we mess with this, we'll start to see little problem indicators. Like this is saying that it can no longer find this reference because it doesn't exist anymore. I changed it. If I go back and delete it, oops. If I go back and delete here, we get it back. But there's no more problem. So it's kind of a quick and dirty tour of the playground. It is just basically going to be where we write our code. Okay, so I'm going to delete all of this stuff. And one thing I'm going to do immediately is just copy this text. And I'm going to paste it in a comment. This is called a block comment. So with these asterisks here. So it means basically I can paste anything within this block. So from here to here. And it'll be commented. And actually, really quick, while I break down this problem, or kind of extract some pieces of information that I think are going to be important, maybe if people in the chat, you could post and indicate how much coding experience you have. It's totally okay if you don't have any coding experience. I'll just try to dwell on certain things or maybe talk about things a little bit more if you have less coding experience, or if generally people have less coding experience. But I'm just trying to get an idea of that. So in the meantime, I'll kind of work through some of these details. So, okay. So let's see. So first of all, this is a pretty important piece of information here. So basically, when we're counting Sundays that fall on the first of the month, it is important to note that this date was a Monday. So we know that for certain. So that's obviously going to inform us. It's going to help inform us like which subsequent days of the week fall after that, right? Because we don't know any of the other dates, like what day of the week they fell on. So this is the only day of the week that we know definitively. And we might say here, if I make another comment, I'll say important notes. And I'll say here, this is important. So we'll say first info about day of week. Okay, and then we'll also say that happens before range to calculate. So what do I mean by that? Well, what I also remembered is that the problem expressly asks, okay, about the 20th century, which excludes this day. So that's kind of an interesting point about this problem. We don't want to calculate the Sundays that fell on the first day of the month in the year 1900. But this is the first date that we're given with a day of the week. So we're going to use it to get the day of the week, but we're not going to count the Sundays in that year. So that's a crucial piece of information just to like remember offhand. Okay. And I'd say also remember that the day of the week cycles no matter what. So what does that mean? Well, what I mean is we don't care about whether it's the end of the month or not, or whether it's the 31st day or the 28th day of the month. We don't care what year it is. The day of the week is always cycling. Like there's nothing that stops it. So it's not like it's Thursday on the last day of the year, and then because it's the first day of the next year, it's now Monday. Like that, it doesn't work that way. It's always cycling. So that's like a useful piece of information. Okay. Everything else, I think, is pretty straightforward, right? Like this is a little bit difficult to deal with, especially this first part, but it's not too complicated. So let's just write it down as how many days in each month as something to keep in mind. Differs for each month. So it's just something to keep in mind. Like that's how many days. Like we need to keep in mind that each month has a different amount of days within it. Okay. The last thing we need to keep in mind is leap years. And let's try to reduce this information. So affects February. Leap year has 29. Non-leap has 28. Okay. Happens every 4 years. And in particular, I'll separate this fact, or rather, what's the more important way of expressing this, which is that happens for years divisible, I should say evenly divisible, by 4. Okay, so that means like the year 2000, that's a bad example, but the year 2004, that's a leap year. Okay, the year 2008, I believe that should be a leap year. 2016, that's a leap year, etc. 2020 was a leap year. Okay, but another thing is that we should specify unless it's a century, must be divisible by 400. Okay, so obviously they're kind of hinting at something here. We have to deal with the full year 2000, right? Because this is inclusive, so it means we finish at the end of the year 2000. So really all we need to think about is the year 2000 divisible by 400. And we can do, can I move this? I don't know if anyone else can see. Oh, I can't, great. Let's see if I can. Whoops. Hide floating meeting controls. Okay, great. Let's see if we can do this. So we'll say, we'll just keep up a calculator, by the way, so that you don't have to take my word for it. You can just believe me when I say that, you know, something is evenly divisible by 400. We'll just use the calculator. So like, for example, 2000 is evenly divisible by 400. Like 1900, that's not evenly divisible by 400. Okay, so there was not a leap year. Okay, so I think we've extracted all of like the really key information from this kind of question. So I think we're ready to basically dive into the code and figure out how we want to approach this problem. Okay, so let me review the chat really quick. Hopefully everyone kind of got their answers in. Let's see what everyone said. So, okay, so someone has recently done a coding bootcamp, so that's great. Really good. So someone else has like about 5 years of coding experience. It's great. Recently started writing some different coding experience. Okay, great. So cool. So we have basically a diverse background with code, but everyone's pretty familiar with code. So that's a really good place to be. because that way I probably won't dwell on anything ultra basic. So it's really good. So glad to see that everyone has pretty much seen some code. And that's pretty much all you need. Okay, cool. All right, so okay, what I want to do next is talk about how to actually approach this problem. So we're counting basically particular days within a year for a number of years. To be exact, we're counting the days, particular days in a year for like 100 years. Basically 100 years, yeah. So we're counting from the beginning of 1901 all the way to the end of 2000. So that leaves us with 100 years effectively. So I know the way that I would think about this problem in particular, and to kind of like expedite the process, I suppose, I'll show you how I think of this problem. And I think this way is pretty straightforward, but I would love to see, again, in the chat or in the comments, or if you want to speak up or interject, whatever, if anyone has any particular other ways of thinking about it that jump out to them. I think it's a good exercise, but yeah, just feel free to interject with how you'd kind of go about it if you have any strong feelings. Otherwise, if no one has anything, particular inclinations, that's totally fine too. So yeah, let's just go ahead and get started, and I'll kind of think through the problem aloud. So when I think about if someone were to ask me, like, let's simplify the problem and think about it that way. If someone were to walk up to you and ask, like, how many Sundays were there last month? So what would you do? You would probably start and figure out, okay, what was the first day of last month, and what was the day that month started on, like what day of the week? And you might say, okay, well, it was like, let's say it's July, and the first day of the week, and we can actually just pull up a calendar here. Hopefully you can see that. And we can just try to like walk through that problem mentally and figure out what we would do. We'd say, okay, well, the first day was a Thursday. So we'd go over and say, okay, there was one Sunday, and then we'd keep going. So we'd add 7 and say in our head, okay, so 4 plus 7, that's 11, right? Okay, so that's still within the month of July in our head. And we'd say that was also a Sunday. And then we do 11 plus 7 again, and then we get the 18th. And that would leave us on a Sunday, but still within the month of July. So now we have 3 Sundays. And then we'd add 7 again, and then we'd get 25. And you can see we just kind of continue this process until we basically added 7 to this, and we ran over the number of days within July. So to me, basically, I guess what I'm suggesting is the most intuitive way for me to think about this is to just go day by day. And the advantage of doing this, I think, is it's very intuitive, but also we are dealing with a computer. And a computer has no trouble doing this. So even though that feels like a really monumentous task for us, like personally, like if you were to sit and go year by year, and then within that, like month by month, and within that week by week and day by day, that would take you a lot of time mentally and personally. But thankfully, we have a computer, so that's not a problem. So I say we approach it like that, and we try to go day by day and use an algorithm to figure out whether it's a Sunday and whether it's the first day of the month. And what we'll do is, before tackling all the complex parts of that, we'll figure out how to do it kind of slowly and iteratively. So basically, make the problem harder a step at a time. So make the problem more complex a step at a time. So if I was to go day by day to start with, I feel like that's a little bit harder for me to think about. So what I'm going to do actually is start going by years and see if I can get that correct first. So basically, I want to write a program that goes 1 year at a time from the year 1900 to the year 2000, stopping just before 2001. So I'm going to introduce a programmatic feature, or like a programming tool that maybe some of you know, maybe some of you don't, but it's called a while loop. And in fact, if I start typing while, I get like a recommendation from the editor, which is pretty cool. And it kind of is suggesting to me that it knows what I'm talking about. So this is a programming kind of feature that's going to allow me to iterate continuously, like endlessly, until I meet a certain condition. Okay, so like you could imagine maybe a while loop would be do this, or you can imagine thinking of it as while this is true, like while this condition is still the case, do the following things. Okay, so we're going to put the condition inside of here, and we'll put the code that needs to execute each time in here. Okay, so we said that our first objective was to, and I'll try to keep tabs on the current objective. So current objective is increment years. So we'll do that first. Okay. So first thing we need to do is maintain what would be like a variable representing the year. Okay, so I'm going to store that piece of data so that we can reference back to it and update it. So let's start with the year 1900. The reason I want to start with the year 1900 is because of this important note above. Even though we don't want to calculate the number of Sundays, we do want to calculate based on the fact that this date was a Monday. And I think later it'll be easier to just simply add a condition that says, hey, if it isn't yet the year 1901, do not count the number of Sundays, which I think is a lot easier than trying to like figure out programmatically what day of the year the first day of January was, or what day of the week the first day of January was in 1901. I mean, we could also Google it. I think that's totally fine if you want to do that too. But I like the idea that they kind of made this problem a bit challenging because you have to start with this piece of data. So I think we should stick with that. So basically what we want to do is each time we iterate, this would be like basically the code is executed again, we want to increment the year. So we're going to say year plus, or year equals year plus 1. So that means basically that you take the value of the year, you're going to add 1 to it and then reassign it. So it's going to update. And currently there's no condition on this, so it will just do this forever, but we don't want that to be the case. We want it to update only on a certain condition. So we already know the condition on which we want to stop, so we can use that. So basically, we're only interested in figuring out the days within the year up to the 31st of December, excuse me, in the year 2000. So what I can say is while the year is less than 2001. Okay, I can also say this. I can say less than or equal to. That means basically either the year is less than 2000 or it's equal to 2000. Keep executing this code. And as soon as you exceed that, stop executing it. And what I'm going to do is use this console tool, which we're only going to use to basically print the content of our answer. So I'm going to say it is, now we need to put this as what's called a string. So basically, in quotes, I'm going to tell the program what to print out after this is completed. And this will complete once this condition is no longer true. So the year is, and then we'll actually include that as an argument to this function. this logging function. Okay, so let's go ahead and run this, what we have so far. So I'll click run. Okay, great. So it completed and it printed what our program spit out. So you see that it printed the year 2001. And the reason it did that is because it entered this loop one last time while the year was equal to 2000. And then it incremented it once more. And then it stopped after that, because once it reached 2001, the year was no longer less than or equal to 2000. And that's when this code was run to print to the log there. This is like a little bit weird because we don't care about the year 2001. We want to stop, but I don't think it's a problem because like we'll do all of our checks in here to know, like we'll do all of our checks before this point. So check for Sunday here, basically check for Sunday on the 1st of the month here. So just a reminder that this would give us maybe some inconsistencies. As long as we handle things before this period, we should be okay. All right. So okay, so let's keep going. So we know that that this loop is working. It iterates correctly. Oh, don't want that. Yeah, the loop is working successfully. Oh, let me check the chat just in case. So we need a function to figure out the distance between 2 days of the week and then start counting once we match a Sunday. That, yes, that's like a really good way to put it. So a function to figure out the distance between 2 days of the week. Yeah, and I think once we get down to handling the days, so we're pretty far zoomed out for now. We're handling the years. So let's zoom in a little bit further and start handling the months. And then we'll keep zooming down until we get to deal with the days. And then we can figure out exactly that. We can figure out a specific way to figure out what day of the week it is and whether or not to count it. Okay. So let's see. Yeah, I mean, we have our years working, so let's move on. Let's move straight to the months. So now what we're going to do, increment the month. So currently, this loop is moving at a rate of 1 year at a time. So basically, if I were to maintain a count, let's just make a variable to store an arbitrary count. Like this count, we'll use it for multiple different things to kind of check our code as we go. So what I'll say is basically count equals count plus 1. So I'll do exactly the same thing I'm doing with the year, but I'll use this for multiple things as we move along. So I'm going to run this code, console log, and I'll say the current value of count is, and I'll say count. And then we can keep track of this count to kind of use it as a debug. Okay, so it's going to tell us basically how many times this loop runs, which is going to be very useful to us when we want to go day by day, because it'll let us confirm that in fact we're iterating the correct number of times, that we're evaluating things the way we want to be. Okay, so this is telling us that basically we're counting out 101 years, which makes sense because basically we know that we're going 1 over to 2001 and we're starting at the year 1900. So from 1900 to 2001, that's 101 years. So that looks good to me so far. And I'm okay with the extra year because we can account for that in our calculation very easily. So it's not a problem. So with that kind of debugging tool, which I would always recommend having, some way to basically check yourself as you go along, we can move on to the months. So I'm going to just do the same sort of process again. Okay, I'm going to say a month equal the starting month, the month that we want to start with. So that's going to be January or month 1. Okay, and then I'm going to do the same thing. I'm going to increment the month. I'm I'm going to put it above month equals month plus 1. Okay, and we'll run it. And the problem is that the code doesn't do anything different than what we already have, because we're not doing anything to affect what year it is based on the month. So let's say add something to our print first to demonstrate like that we have the same kind of a problem here. So this is +1 more than the count is, because the count started at 0 and the month started at 1. So just clarifying, that's why that's 102 and that's why this is 101. And let's clear this out because the log is going to get a little bit messy. Okay, cool. So we cleared the log. All right. So what we need to do is basically move the iterator faster. Like currently it's moving 1 year at a time. So what we want to do now is make it move 1 month at a time. So we want to not move faster, but do an execution more times. Do an execution for each month of the year. So what we're going to do is basically, we are going to now, I think, check that the years should be incremented to know when we've actually reached the year 2000 going month by month. So what I'm going to do is I'm going to add another calculation here. I'm going to say, instead of incrementing the year every time I increment the month, I'm only going to increment the year whenever the month reaches a certain limit. So in that case, I think in this case, it should be 12, right? Because there are 12 months in a year. So if I'm counting month by month, instead of counting by years, I would say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 1 year. Move to the next one. And then 1 through 12 again. That's another year. Move to the next one. So I'm going to do.
Page?
Oh, yeah.
Just 1 second. We do have 2 questions or kind of 2 comments in the chat. I just wanted to make sure you see them.
Oh, thanks. Yeah, I did not.
Yeah, of course.
Thank you. Yeah, okay. So, oh, thanks. Yeah, okay, great. This is a great comment. Yes, so it's like having multiple hands of a clock, but for year month. Yes, that's exactly what we're doing. Yes, so like if I could do a visual representation of kind of what we're trying to approach, you can imagine one hand is moving slower. That's going to be the year. One hand is moving faster. That's going to be the month. So like if the months are going round, the year is going round more slowly, like as we complete each cycle of months. So like if it were a weird clock where it's like 1 through 12 for the months, and then after you've completed all 12 months, then a year ticks by, right? So that's kind of like what we're looking at. And you could see we can zoom in even further and do the days. So after X many days, then a month goes by, and then after X many months go by, then a year goes by. So that is a really good, like a really good analogy. Okay, so let's try this out. So basically what we're going to say is, I got rid of my year increment, and I'll say basically, if the month exceeds 12. Now, why am I saying if it exceeds 12? Well, what this represents is basically, we imagine the loop, let's imagine the loop is iterated exactly 12 times. So what that would mean is that a year has gone by, and what we should do at this point is reset to month 1 for the subsequent checks that we're going to do. So we should also place our kind of recalculations based around where we plan to check for whether it's the Sunday, the first Sunday of the, or whether Sunday falls for the first day of the month. So let's go ahead and do like a check first, and then we'll figure out if we need to do any adjustment. So if the month exceeds 12, when we re-enter this loop, we don't want to let it get beyond that, right? So what we want to do is first reset it. right? To imagine that it's the new month of the new year. And then at this point, we want to increment the year. So basically, we've moved the year increment outside of the main piece of code here, and we're moving it into this condition. So only on this condition will we basically update the year. And we'll reset the month back, right? Because imagining that clock, like, I think works really well for this. The clock is a cycle, so it's going to cycle back each time. Months aren't going to increment forever. We only want to represent the 1 through 12 months. So that's why we will kind of do this here. And if we run this code again, we get some different numbers and some different output that may work, I think works pretty well for us so far. So some things look a little bit weird though. And maybe we can make some adjustments, but I don't think it's too bad. So starting off first, we notice that the year is 2001. So that's, we already encountered that before. We know that that's going to be the case because it's going to basically leave us with the last day of the year rolling over, or the last year kind of rolling over, but it's not going to re-enter. Like it's not going to come back into this loop because it won't meet this condition. So it'll stop. So it's not like we'll calculate the Sunday for that day because it will already have left. So that's good. But in this case, the month is 2. The month is 2 because we're starting on month 1 and we reset to month 1, but then we do our increment after here. So what we could do is maybe move this to the beginning here. And this is kind of a weird trick. I don't have really a formal way of like describing why you might do something like this. And there's better ways to do this, certainly. But one way you could handle this kind of like weird problem is to set the month to 0 to begin with. And then when it starts, it will start off as 1 instead. So then this way, basically the month ends on the 1, which you would expect, without that little like math error. Yeah, I mean, there's probably a better way of maybe thinking about this, but yeah, I don't mind doing it like this. I can kind of like, it makes sense to me, so you should do what makes sense for you. If you rationalize the problem in a different way, that's good, whatever helps you solve the problem in particular. But for me, it kind of makes sense. It's basically like I'm starting the like the clock, so to speak, when the loop begins. So that's kind of how it works out for me in my head, at least. Okay, so we've handled the months. Okay, now let's jump to the year, or sorry, the days. So let's get more zoomed in. And let's try to iterate on the days. So we're going to now handle that day hand and basically figure out what day of the year it is. So the easy way to start, obviously, let's go back here. Let's maintain a store for where we're going to keep our day. We can do the same thing here and start on day 0 to kind of avoid that same issue that we mentioned. And we can increment the day in the same way that we're doing here. So increment it up, no problem there. We'll kind of run this. And by the way, we can use this here. This count currently is indicating to us how many times the loop iterated. And you can see that this still tracks, but it's off by just 1. Just like the count was off by just 1 when we calculated the years. It's going to be off by just 1 when we calculate the months as well. So this is kind of a verification of our work so far to confirm that, in fact, we have counted the correct number of months for the years that we're looking at. So basically from the year 1900 to the year 2000, if we subtract the erroneous 1 that we get from doing this 1 extra time, we get 1212. So there are 1200 months in 100 years, and then add 12 more for that one extra year. So from 1900 to 2001. Yeah, so hopefully it makes sense to you that this is helping us basically maintain that we have a sense of accuracy. So hopefully that part was clear where the count is coming from. Okay, so let's go back to our day. What we need to do now is zoom in further on the clock, and we need to say, actually, the month shouldn't increment every time. We want the loop to run for every single day. So what we're going to do is only now update the month every time the day reaches 30 or like the end of the month. Obviously, we have all of this stuff to deal with too. Keep that in mind. But what we can also do is like ignore it for now and just start with 30 days in the month. So what I'm going to do is basically do exactly what I did here. But I'm going to basically just default to 30 days instead of dealing with the complex part of the code, which we'll get to in a second. And again, just kind of like keeping the complexity like away from us until we're ready to deal with it is usually the way I kind of approach these problems. But this can help me quickly verify that my logic is still correct as I go. Excuse me, yeah. So we're going to take the same approach that we did here. We're going to basically focus on the end of the cycle. So here we checked if the month exceeded 12. That means that we need to cycle over. Same thing we're going to do here for the days. So if the day exceeds 30, and I'm just ballparking 30, I mean, I could have chosen 31, representing what I believe is actually to be most days. Yeah, most days in the year actually have 31, but 30 gives us a nice round number, and we can do a quick kind of scratch calculation to verify that what we're doing so far is like correct. So basically, we're going to take the same approach here. We're going to reset the day. So it's the end of the month. We went past it, but we haven't done our calculations yet. So we're going to reset. And then what we're going to do is we'll increment the month only in this case. So only increment the month in the case that we reach the end of the month by days. So we're going to take this calculation away from here. We're going to put it in here. Okay. All right. So once we've done that, we can run the code again and kind of see where we're at, because this should have updated like how many times the loop will iterate, because now the years will come by even more slowly. It will take even longer to reach a year because we've affected how frequently the months update as well with this code change. So let's run this again. Whoops. Okay, and if I move my little widget here, okay, we see we're at something that looks pretty, I think this like should seem a little bit appropriate. Let's actually change this to 1901. Oops. Just because I want a nice number to deal with. I want to deal with around 100 years. And it looks like we already kind of have a little bit of a bug, which is, I think, kind of cool. And maybe you already noticed what it is, just evaluating the count. But let's see if we can kind of figure it out. Let me update this message here and our objective, because that's what we're working on right now. And the day is space, and we'll say day. Okay, so what's wrong here? Well, basically, we've gone 1 month over. We've gone like an extra month of loops. So, you know, previously we were off by 1 over here, which was acceptable, but now we're off by like 1, the 360, 31, and if we remove that one, we're still off by a full month worth of days. So we need to figure out basically where we're limiting incorrectly. So let me change, I mean, we can play with it a little bit. Let's see maybe if we can limit it instead by saying if it's equal to 12 at this point. Because basically, if I get to the end of the month and I increment it again, maybe that won't work. Let's see. So, but let's take a look and see what happens. Sometimes you can like kind of mess with this stuff. Get different. Okay, so now it takes us down considerably. But maybe that's more appropriate. So what is the number that we're actually targeting? Let's see. So we're targeting, let's see here. So 1901 to 2001 is going to be 100 years. So that should be 100 times 360 is the number that we're trying to work with, which is basically 30 times 12. 100 times 30 times 12. So we should be getting 36,000. So I don't know if anyone happens to see anything wrong with what I have offhand. Let's see if we can try to, oh, maybe we need to move this. Day 30. Oh yeah, that might be it actually. Let's try moving this up. Let's try that. No, that just kind of puts it off a little bit more.
Hey, Paige, I had a question.
Yeah. Sure,
Earlier,
yeah.
Earlier you had months. You were trying month equals to 12, but you used 2 equal signs. Is that valid syntax?
Oh, yeah. Sorry, yeah. That's a really good question. I kind of just blipped over that, mainly because I was just trying it, and if it worked, but it definitely doesn't work in this case. So yeah, that is valid syntax. And I can definitely explain that really quick. So regardless of whether we use it. So what this is doing is basically, it's called an equality check. So I guess you've noticed I've been using this equal sign, which I skipped over, to make assignments to variables. So like here, I'm updating the value of month to be the number 1. Okay, but what I'm doing here is, this is a condition for this piece of code. So I'm using an if statement to determine whether to run this piece of code. And inside of this must be a condition indicating whether or not this code's going to run. So here I've been using things like greater than or less than or equal to. What this is saying is, like, if I had an equal sign here, it would be an assignment, and we don't want to do that. We don't want to update the value of month. What we want to do is check whether month is equal to 12.
Sorry, my question was, I'm used to seeing a triple equal sign.
Oh, a triple equals, yeah. Okay, well, a triple equals also works. That's actually even a little bit deeper. So with JavaScript, you can use either or. This is considered a, I think they call it a strict equality, or like a, yeah, like a strong equality or something like this. But basically what you're saying is either they must be exactly the same thing. It usually with numbers, it's not really a problem. Like if you're just comparing 2 integers like this, 12 and 12, I think there's not really a world where these would give you different answers. So triple equals versus double. But if I were to compare something a little more complex, like an object, so like in JavaScript or TypeScript, I can make an object by saying like this, be like something like this, like a very simple object. If I were to like make another one, like this, and say A2, if I use double equals, if I'm remembering correctly, these would be equivalent. if I'm remembering that correctly. There might be a case where they're not. If I was using triple equals, though, they would not be equivalent because they're fundamentally two different objects. I don't know if that makes sense.
Yes, that makes sense.
Okay, cool. Yeah. That was, yeah, a good clarification to make. But yeah, this is totally valid. A lot of people will refuse to actually use the double equals because of that exact problem. I use it because it's, I guess, kind of like a bad habit. But yeah, triple equals, I would say you should definitely prefer that. So I know we're running pretty near the end of time. And I would like to at least get you a little bit closer to solving this problem. I mean, we can obviously solve it next time, but let's spend a little more time to see if we can at least resolve this particular issue. So one thing I had in mind was that maybe the month here, this offset, doesn't need to start at 0. Let's see if that gets us where we want to be, and it does. Okay. So I think the reason that this now needs to be at 1 is because now our clock, our effective like clock, like that really good analogy that was in the chat, it's now moving at the speed of days. And when it was moving at the speed of months, that offset was necessary. Because that's what controlled, basically, it dictated how many times we looped. But since the month, like the number of months, isn't dictating the loop, it's dictated by the number of days, that offset is like starting at 0 isn't what we want to do. We want to start actually at the first of the month, because it's going to be the first of the month for 30 loops until we reach the second of the month. If we started at 0, we would be behind, if that makes any sense. Yeah, it's a little bit difficult to explain these like loop counts sometimes, but hopefully that's clear. And you can maybe try it out kind of like as you go too, to maybe help clarify the reasoning in your head. But basically, if I set this to 0, we get an extra month because we're behind. So it doesn't think it's the end of the year yet. So we get those extra days. But then once you get past 1901, it like will work normally again because this will reset it effectively. So basically it gets to like month 13 effectively, but only for 1 year. So that's why we get 1 month extra. Hopefully that is kind of clear. Okay, so we're back to working great. We're off by 1 day, but that's fine. That's totally okay because we'll account for that at the very end. That's no problem. So again, I know we're going a little bit over, but I'm just gonna spend 5 minutes to try to get a little bit deeper into like dealing with the months themselves. Or actually, maybe I can take a poll. So that way we spend our time effectively. Who is interested in seeing the days of the week? And who's interested in seeing the figuring out the months, like how to figure out when to change months, like if it's a leap year or that kind of thing? Or if you're interested in demonstrating, because hopefully maybe you can try to resume the rest of the problem independently to see if you can figure it out. And I can also tell you the answer before we quit, or I can not tell you the answer. And you can just try to keep working on it. But yeah, with these last minutes, I'd be curious to see who's most interested in like kind of understanding the logic behind either figuring out how we know what day of the week it is, or how we know to change to the next month. So maybe just a quick poll. If no one feels super strongly, oh, do we have chat? I have no preference. Okay, cool. Okay, cool. All right. Well, I will say that the day, like what day of the month it is, I would prefer day. Yeah, I figured people would prefer day of the week because if you think about it, the day of the month is pretty well described by this algorithm. And if you just kind of like very carefully evaluate this condition, you can figure it out. Like basically, you know the day, and you know the month that it is, so you should be able to figure that part out. I think the day of the week part is kind of interesting because I think people would approach it a little bit differently, depending on who you are. But let's try to think about it. So first, what I'm going to do is reset this back to the year 1900. And the reason I'm doing that is because, and this worked great, right? Because we're doing a flat 360 days per year. And it gave us one extra year, so 1900 to 2001. That makes a lot of sense. Okay. So like the way I like to think about this is basically that if we're thinking about the clock analogy, the days of the week almost rotates at a totally different, like it doesn't acknowledge any of the other variables that are involved here. So like if the day is the 31st, if the day is the 22nd of whatever month, it doesn't matter. If Sunday came before, then Monday comes next. That's always how it's going to work. So the way I like to solve this problem is basically maintain a separate day of the week variable, if you will. Okay, and initialize it to something that actually makes sense. I'm starting with 0 here, but we're going to change that in a second, and you'll see why. If we think about the days of the week in terms of like integers, which I think is a pretty convenient way to describe it, we can think of it as an integer that rolls over every 7 days. So you could think of it as 1, 2, 3, 4, 5, 6, 7. So this would be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday again. Okay, so if that kind of makes sense to you, then really what you can do is think of it as, I'm trying to think of a way to not kind of like cheat with, I guess, my background in understanding how to approach this type of problem. But maybe I'll just kind of describe the function, which is the something that you probably want to be familiar with anyway, and not think of it as cheating so much as like a helpful tool. Okay, so there's this thing. If you haven't heard of it, great. Hope I'm introducing you to something useful. If you have heard of it, then you know where I'm going with this. There's an operator that's common in computing. It's very common in computing. It's considered a basic operator. It's called the modulo operator. You may have encountered it in mathematics too, depending on how far you went in mathematics or what you ended up looking into. But basically, it's going to give us the remainder of division, and that remainder is always going to be an integer number. So it's whenever we're left with whatever is left behind after when one number is divided by another. So it's as described here. And yeah, it's typically called the modulo operator. So basically, if I take one number modulo another, it's going to try to divide that number by the other number and tell us what would remain if we were to do so, if that makes sense. So basically what we can do is, if I have an integer representing the day of the week, then what I can do is I can take the modulo of that with the number of days that we always have in the week total, and I can create like a sort of algorithm that rotates. So basically, as we're moving along our days, we will also increment the day of the week. And then in our checks, we will check if basically it has been, if that like integer has rotated around yet by taking the modulo of the current day with the total days available to us. So maybe if I just start writing the code, that will make a little bit more sense. So what I'm going to do is I'm actually going to make a separate function to handle this condition a little bit more succinctly. So I'm going to say is a Sunday. So I'm going to call this function is a Sunday, and this function's basically going to tell me if today is a Sunday. Now I'm going to consider Sunday to be a little bit complicated because it's like, it's the beginning of the week, but it's also the end of the week. So you could either say it's modulo 6 if you wanted to, if you started at 0. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then Sunday again. Or you could say starting at 1 that it's 7. And you'd say 1, 2, 3, 4, 5, 6, 7. Because either of these works, because basically if I take 7 divided by 7, the remainder is nothing. If I take 7 divided by 0, the remainder, or 0 divided by 7, the remainder is nothing. So either works, but basically what we're trying to figure out is if I take the day of the week represented as one of these integers, and I perform this modulo operation with the number 7, so the total number of days of the week, since Sunday is the end of the week, whichever day like gives us 0 for that operation, that is a Sunday. Hopefully this makes sense. This is like kind of a pattern that you learn like early on because it comes up a lot when you're iterating and you want to figure out different rates of iteration as you're moving through a loop like this. So like I want to track multiple things at one time. Modulo is really useful because I can say, well, as you're moving through this loop, I want to know about every 7th iteration. So that's basically what this operation is going to tell us. It's basically saying, hey, do something on every 7th iteration. And we keep track of the exact number because we want to know in particular about this like unique 7th iteration. So the 7th iteration after a certain number of iterations, if that makes sense, like Sunday in particular is most important to us. Okay, so what I'm going to do then is continue this function, and I'm going to say basically all this function does is it returns, so it's going to return a value. TypeScript, I can actually specify what it's going to return. It's going to underline it because it's saying it's a problem that I haven't returned a Boolean, which is going to be true or false. And I'm going to say true or false, is today a Sunday, given a particular parameter. So I'm going to add this parameter, day of the, I'm going to say this is a number. So we're going to send in a number, one of these, 1, 2, 3, 4, 5, 6, 7. And we're going to return whether or not it's a Sunday. So we're going to say basically the parameter. Okay. Oops. Spelled that wrong. Modulo, this is the modulo operator. In TypeScript, it's a %. I'm pretty sure it's, I haven't seen anything else in other languages. Maybe, I think you can sometimes use like, in some languages, it'll be like mod, something like this. It'll be like whatever you want to take the modulus of, and then like the divisor, if that makes sense. Okay, so here I'm going to say day of the week mod 7. Okay, and then that is going to give me the remainder itself. So I can't return that because I need to check what the remainder is, and I'm interested if the remainder is 0 because that's Sunday. If I wanted to check for a different day, I would check like one of these other numbers, if that makes sense. So I would check like 4, or like something else if it was one of the other days of the week that I was interested in. But because we're dealing with the last day of the week, which is Sunday, then I'm checking for 0. So that means this is a Sunday. Okay, so the problem, well, yeah, it kind of is a problem. I mean, we can still do it. It just won't make a lot of sense, but we'll do it anyway. So what you would do then is once you had correctly calculated the days of the month that remain, the number of days in the year based on whether it's a leap year, etc. At this point then, you could basically iterate on, or you could successfully check the day of the week. What I also need to do is add a day of the week for each day that occurs, but then I need to reset it if it's a Sunday. right? Because we want it to loop back around to accurately represent the day. And notice I don't put it in a condition because, again, like I said before, no matter what other circumstances there are, the day of the week keeps moving along sequentially. Like there's nothing that stops it from being anything in particularly like unique. Yeah, okay, so basically what you'll then do is you'd say, okay, reset it back to 1 if it is a Sunday. So like if we determine that it is a Sunday, we need to go ahead and increment it successfully and set it to Monday to update it. And if it was a Sunday, then you need to go ahead and say something to keep track of how many Sundays there have been that are on the first day of the month. So you'll also do that at the same time. And what you might say is, if you know, basically day is equal to 1, and we'll use triple equals as referenced earlier, because that is the better thing to do if you're using TypeScript or JavaScript. So if it's a Sunday, or basically within this piece of code, we'll also check if it's the first day of the month, because this represents like the date. Then I'll go ahead and add another variable here called Sundays. Start it off at 0. We'll say Sundays plus equals Sundays plus 1. So reset the day of the week back to Monday after we've checked whether it is a Sunday. Reset the day, reset the month, and continue the count. And that's basically the way I would approach this problem, aside from the leap year stuff, which again, like I said, you can kind of do separately. So we can print this out if we want. It's not going to really mean much. Oh, whoops, it's 0. What happened? Is it Sunday? Day of the week? We messed up our function. I'll leave that to the I'll leave that to you attendees since we're out of time. But maybe I can figure out what's wrong. But I don't want to hold you too long, so I'm sure this is something small that can maybe be figured out pretty easily. So maybe if we just move this. No, I doubt that. Sometimes it works, sometimes it doesn't. Oh, maybe I'm like resetting this by referencing this globally, which is a bad idea to do, and is another conversation for another time. Yeah, it still doesn't like it. Maybe you should set the initial value of day of the week to 2 as stated in the problem. Oh yeah, you're right. Actually, I think it should be 1 because it's a Monday. Instead of 0, if that makes sense. I think you're right. That might be it. Let's see if that's it. Let's see. That's still 0. I don't know why it's just staying at 0 though. It's almost like it's not being updated. One thing could be too that we're never entering this function. Let's test that. Say I'm here. So making sure that this happens. Oh, and I froze it because it's printing like 36,000 times. Okay, so it's definitely entering this function. Oh, did I freeze on Zoom? Uh-oh. Oh, I froze? Oh, wow. Okay. Okay. Yeah, wow. I totally froze the code. That was cool. Okay. Well, yeah, so don't do that. Don't print 36,000 times. So basically, I think I messed up this function. If is a Sunday, day of the week plus 1. Maybe I have to do this later. Yeah, no problem. Thank you, Damien, for joining. I really appreciate it. Hopefully, at least I clarified what was at least what's happening with this problem and how I'd approach it. So that was the main point of these sessions. If you find them helpful, I'm doing one more not next week, but the week after next week. So yeah, I enjoyed this 360-day year calendar. There seems to be no Sunday. That's the first of the month. Oh, I didn't even think of that. Maybe that's it. Yeah, because I did this problem before, and I did the leap year stuff first. Oh, I bet you're right. Yeah, that's funny. Okay, well, yeah. Let's do it like that. I bet you're probably right. Let's see. I didn't even think to just delete this. And let's move this back. Yeah, it totally updates. You're totally right. That's it. So that is the problem. Yeah. So if you have a 360-day year calendar, there are no Sundays on the first of the month. So that is the answer. Okay, cool.
That was awesome.
Yeah, but good note. Okay, cool. Well, yeah, hopefully I'll see you all next time, and you'll tell me if you solved the problem. I know the answer. So if you come back, I'll tell you if you got it right, or you can submit it. But.
And I just want to say, well, thank you so much, Paige, one more time. And that we're going to be holding, I mean, these sessions are going to be in person as well. So if you want to come to the library, we here at the library actually multitasking, doing hybrid, online, virtual, and in person. So you guys welcome to come to the library next Tuesday. Not next Tuesday, August 24th.
Yeah.
Either 24th. In person or virtual, we're going to be here. Okay.
Yep.
All right.
Okay.
Thank you.
Okay, bye.